Hello, Kanaiza.
Hi, Brenda. Hi, everyone.
Hi. So I think we'll get the YouTube link. I'll share even on the office phone, WhatsApp status, and the group, so people who want to view on YouTube can proceed. Thanks, Bongo. Kanaiza, remember to check the chats on YouTube. If there are any questions coming in, you let us know so we can answer them.
Okay.
You think I should start sharing my screen now? To have the title slide. Wango coordinator.
I think
we just wait.
Give the guests like around it's 5 minutes to 10. So actually I can be playing a video from YouTube, like the previous Arduino Day, the previous Arduino Day celebrations that we've had. So we can wait for some time.
What do you watch cartoons?
Actually, watch cartoons. Okay.
I can't hear the audio, Wango. Does it have audio?
It has a. Can you hear the audio?
No. So maybe when you're sharing your screen, just make sure you are sharing the, what is it called? The tab with the video only.
Okay, let me try that again. Okay, Brenda, I've shared with you the link. Kindly assist me in link the video.
Okay.
Do you think it's because you have your earphones on? Wango. Could that be it?
Actually, I've been experiencing some audio and sound issues on this laptop, so I really can't tell. So most times I just have to restart the laptop.
Who's playing the video now? I still can't hear.
I am.
I don't hear any audio.
But the audio is very low. So my speaker is maximum. Can you hear?
No.
Can you hear now?
Still no audio.
Richie, could you try? I don't know why it's not playing the audio, though I feel like the video is, like it itself has very low, like the volume is very low. Can I share with you the link? You try for your end.
Or you try a different video. Can you try the in challenge video? Because if that doesn't play, then I.
Hello, everyone that's just joined us. Thank you so much. We'll be starting soon, going over some technical configurations before we start. But thank you all for joining us this morning.
Can you hear this? Wango, could you hear that?
No, it sounded so low.
Is
You can
it?
try on my end. Let me try on my end then.
All right, maybe it's my laptop and Wango's laptop.
All right, let me try and share mine then. Oh, there's actually a part where you have to click share sound. Have you seen that when you share screen? There's like a small button. Okay. Let's see if it works.
Okay. Yeah, I can hear you. I can hear it.
My name is John Guru from Belmug High School. I'm in Form 3, and for me, I've learned a lot about Arduino. It's an instrument that is used to make work easier. When you have different ideas, you can use the Arduino to simplify problems and help the community and the society.
My name is Michelle Kamau. I come from Belmug High School. I'm in Form 3. today was World Day for Arduino, and I've learned so many things about it. And we have used it in making traffic lights.
Oh, I've really enjoyed interacting with the students, seeing some of the exhibitions that they're showing and the questions they're asking, getting to interact with them and learn from them as they learn from us. It's been awesome.
Nice, thank you. That video brings back memories. So you can see we have people joined us. Sorry about that. So yeah, we'll start off. Let me just share my screen with the presentation and welcome everyone. I hope everyone can see my screen. One of my colleagues just say yes.
I can see it.
Nice, great. So welcome everyone. It's morning here in Nairobi, Kenya. So my name is Richard Biko. I mostly go by Richie. And today we are celebrating the Arduino Day event. And so I'm really excited and happy to start off this introduction, but also I'm excited and happy to see the young makers and innovators and change makers who are able to join us today. And I'll share a bit about myself. So my background is actually in peace building and development, but I'm a big tech enthusiast. So I don't have any technical engineering background, but I love all things to do with tech, especially in terms of like social impact. I believe tech has a huge potential in changing the world, which it already is. And today, and I lead the In Challenge program at Global Minimum. And I'll share a bit more about the organization and what we do, and also why this day, Arduino Day, is a special part of organization's history and development. Learning, innovation, and technology is a big part of what we do at GMIN, and over the years we have used the Arduino platform to help young people in Kenya to explore, tinker, create, and solve problems using this platform. And on behalf of the GMIN team, we would like to celebrate with you all around the world. And so before I move on with my presentation, I know there's a couple of you guys are joining from different places. So if you can go on the chat box and just introduce yourself, you can state your name, I guess what you do, where you're calling from, or where you're joining us from. You can mention the country, city, town, and also like a fun fact about yourself, okay? So those are 4 things: name, what you do, where you're calling from, and also a fun fact about yourself. So you can go on the chat box if it's possible. I won't be able to read all of it, but I'm hoping like the other participants and guests can be able to see like who's among us today. Okay, let me just get my presentation ready. All right, now I'm gonna minimize my screen a bit so I can see some of the responses. Oh. I just want to see the chat. Okay, great. Yeah, so we have Wango Kaisu. She's calling from Uganda. And fun fact, she loves eating. Okay, that's great. Thank you. Anyone else? Just go on the chat. I'll read maybe the next three because for the sake of time, we'll just need to proceed. So if you can, just please. Thank you, Dan. Dan from Canada. It's 3 a.m. Wow. So you're very sleepy, I bet. Thank you so much for joining us. I hope it's not a pandemic insomnia. I've been getting those for quite some time. But thank you, Dan, for joining us. Last one, I'll just introduce the last person. Steve Gitai from Kenya. Thank you, Steve. Glad for you to join us. And Kanaiza from Nairobi, Kenya. People are not telling me the fun fact about themselves, but it's okay. You can keep on continuing that on the chat box so that everyone else can know like where people are calling from and just a bit about yourself. Okay. So thank you for this. So today we're really excited again to be here, and this is the schedule for the day. So I'm starting off with introductions. I'll try and rush because I know like we didn't start on time. And then we have an introduction to Arduino, which my colleague Wango will also help us with. And then after that, we'll have a panel discussion, which will be led by Brenda. And then we'll have demonstration, hands-on activities, more demos, and closing remarks. So that's the schedule of the day. We're hoping to end right before 1 p.m. East African time. But we hope it will be a day full of learning and also sharing and celebration of this day. Oh yeah, before we move on, this is also a global event. It would be great like if people can go on our Twitter, on our social media pages. So we have a Twitter, and Instagram, a Facebook, and also maybe one of my colleagues can drop the links for our guests to join us on social media. The hashtag is ArduinoD21. And also you can follow Arduino on social media, on the social media pages. So before that, I'd like to ask like people to follow us whenever social media platforms they're in. And also you can use the email to contact us for information that you need to know about GMIN much later. Okay. Yeah, so I'll start off with introductions for Global Minimum and what we do. So Global Minimum, or in short, GMIN, is a youth development nonprofit organization that is committed to providing opportunities to inspire young people between the ages of 13 to 26 years to become active leaders, innovators, change makers, and social entrepreneurs. We believe in young people's limitless potential and provide enabling environments for them to access programs that encourage them to collaborate with one another, to think critically, to develop creative solutions to challenges they've identified in their communities, and build confidence necessary to communicate those ideas, all while providing continuous feedback and mentorship. Learning and mentorship is also a really big part of like what we do here at GMIN, and that's one of the main things like we offer young people through our programs. So our mission as an organization is to catalyze a culture of innovation through hands-on learning experience, creative problem solving, and leadership skills among youth. And a bit about our history as an organization, it was co-founded by four young, actually I think they were around like 18, 19 years old at that time, four young friends who met at a college called United World College. And one of them was Sierra Leonean and three were Danish. And the organization programs and operations started in Sierra Leone. And so we worked on a bunch of community projects at that time. And then we shifted gears in terms of like really offering young people an opportunity to be part of solving problems in the community rather than just bringing solutions to people. We wanted to see like how we can co-create solutions, or not co-create, understand problems together and seeing like how we can co-create solutions. So that's a bit about the history. And then in 2013, one of the co-founders came to Kenya, and that's when I joined as a volunteer. And also we had a program in South Africa that also branched off to become its own, and they offer coding programs for young people back in South Africa. So that's a bit about the history. It is also important. So I want to go really quick about the programs. One of the programs we offer at GMIN is called the Innovation Challenge. And this is offered both in Sierra Leone and Kenya, where we operate. And this program is also known as Innovate Kenya, and it's an innovation contest for young people between the ages of 13 to 20. And this program offers an opportunity to identify problems they see in their community and think creatively about how they can solve that problem. Finalists selected from this program from this contest are invited for an innovation bootcamp where they receive mentorship, project funding, workshops on leadership, business development, and prototyping. So prototyping is also one of the big things that we do, and Arduino has been a really huge platform in assisting us with that. Other program we currently offer is called the Innovation Lab program, or InLab, and this is an after-school program that provides young people in partner schools with the opportunity to learn user-centered design thinking, collaboration, and creative thinking through a carefully crafted design curriculum that's focused on science, technology, engineering, and mathematics, STEM in short. As mentioned, this program currently we run it at a community center in Dagoretti, and also we run it with partner schools, like community partner schools that are joining us today. So currently we're running at 5 schools, but this program we're hoping to expand through Kenya for now, hopefully Africa much later, but we're hoping to expand through other parts of Kenya, especially in areas where young people have limited access to digital tools and technology for them to learn. One thing before I move on to the next part, I know I've talked about innovation tech a lot, but at GMIN, when we talk about innovation, it can be about like creating something that has never existed before, but also it's about like using previous knowledge or previous information, previous ideas, projects to build up on that and to solve problems in our society and in our community. And also for us, innovation just doesn't mean tech. I know this day is about tech, but for us, it's not just about tech. We believe innovation can cut across different fields. So we can also use the arts to innovate and solve problems. So I just wanted to put that disclaimer before we move on. So I'd like to share about the outcomes as GMIN. So we've had over 1,500 alumni. So those are young people who have gone through our program, both in Kenya, Sierra Leone, and South Africa. 80% of them have been accepted to university and gap year programs, and we're really big on gender diversity. So we ensure like 50% of the participants in our programs are balanced, so they're girls. And you can see some of the other highlights over there. I won't go over all of them, but our youth have also been able to present at local and global platforms, present their projects, innovations, as well as actively participate in calls to actions for a more just and equitable world. And also we have alumni who've been able to establish and start social enterprises and created employment across the globe, which I'll share a bit more about in the next slide. I'd like to highlight a few stories that we have. The first story I'd like to share is about Rehema Wasike, and she was a graduate of our program back in 2017. And she worked on at first she was starting a blog to really raise awareness about mental health, especially among young people in high school. And through coming to the camp, she was able to learn more about like technology, and she started testing out like how she can create an app to help with mental health. And through like her and the team's effort, she was recognized by UNICEF Africa as a mental health and youth advocate. And now Rehema is a software engineering student, and during her free time, she still helps create mental health wellness videos on social media to destigmatize mental health and reach more young people to that. The other lady I'd like to highlight is Rebecca Ombud. And Rebecca graduated from both our programs, both the Innovation Lab program that we run in the partner school and also the In Challenge program. And through mentorships, she was able to to apply to the Code Hive program, which is a highly selective program for young people to learn about programming and coding. And it's run by Accurachicks. And through that program, she was also able to secure an internship at Twiga Foods just this year. So this just shows like a bit of the power of like mentoring young people, and also like how technology and digital spaces can open up an opportunity for them. Next, I'd like to highlight these three young gentlemen, and I'll just read their names. It's Larry Swanzoe, Ian Otula, and Jeff Kangata. These are just a few examples of some other social entrepreneurs from GMIN. These three young innovators have founded and co-founded Tambua Health, excuse me, Tambua Health, Vuma Biofuels, and School. Oof, I've talked too much, excuse me. Yeah, so these three have founded and co-founded Tambua Health, Vuma Biofuels, and School for a Village, which are enterprises that are solving challenges in healthcare, energy, and education. Even amidst the pandemic, they were able to grow their enterprises and created and offered employment opportunities for over 100 people. Their enterprises employ people from Nairobi, Migori here in Kenya, Cape Town, South Africa, Bajol in India, London in the UK, and San Francisco in the USA. Also, these young innovators have been able to collectively fundraise over 3.9 million US dollars. In Kenya context, that's over 400 million Kenya shillings. And this just shows like also the great power, and they're all, I think, still under like 25 years old. So they're really making an impact across the world with their ventures as well. The work that we do is not just done by ourselves. We have volunteers, mentors that contribute their time and volunteer their time to help like our young kids with whatever help they can, whether it's by donating kits, whether it's by just coming to talk to them, coach them through their projects and ideas. And I'll just like to mention a bit about like the partners we also get huge support and funding. So there are corporations like the Lemelson Foundation, Rockefeller Foundation, Outdesk, the All Foundation, Siegel Foundation, that also support our vision and mission of supporting the young people. Before I move on, at this point, I'd like to also introduce the people behind the scenes who help make the organization run. So if the GMIN team can start, I'll start sharing my screen now. The GMIN team can just come on and introduce themselves to the team. You can share your name, what you do at GMIN or your role at GMIN, background, and what else? What would you like to hear from them? And a fun fact from them, so they can choose what they would like to share. We can start with Luango, who's been the lead coordinator of everything to do with this Arduino Day.
Okay, hi guys. Welcome to Arduino Day celebration. My name is Wango Okaisu. I'm a program associate at Global Minimum, mostly working with the Innovation Lab program. And I'm so excited to see some of our community members from InLab. Hi, Sendorcas. I also see Mr. Kelly, one of the teachers from St. Teresa. You are all welcome to join us. So I think I already shared my fun fact. It's that I love eating, and I'm sure I'm not the only one. Thank you.
Nice, thank you. Yeah, I can go next, Brenda.
Hi everyone, my name is Brenda Nyakova. I also a program associate at Global Minimum. I work specifically with the In Challenge program, commonly known as Innovate Kenya here in Kenya, which Richie introduced as the Innovation Challenge for high school students. My background is in electrical engineering, and at GMIN, I mostly design workshops and programs for the kids. So even in April, we're looking forward to hosting a group of innovators to see what solutions they're trying to create for their communities, and just help them, equip them with skills that will enable them to realize these solutions. So welcome all today to Arduino Day, and we'll meet again during the panel discussion. Thank you.
Nice, thank you. Doreen, you can go next, and then Millicent.
Hi everyone, my name is Kanaiza Doreen. I'm one of the In Challenge program interns, and my role is to reach out to young people out there to encourage them to be part of the In Challenge, to become innovators. And my background is communications and literature, but I found myself at Jimin because I'm a people's person, and I like to see young people become proactive and vibrant. And yeah, I like being part of this team, and I'm so happy to see the turn up today. Thank you for coming. And fun fact about me is that when I'm free, I like making shaggy mats, and some of the things I do something like this. So yeah, that's about me. Thank you.
Thank you, Kanaiza. Millicent?
Hello, everyone. Good morning. My name is Millicent Mudeu, and I am also a program intern at Jimin, and I specifically work for or under the In Challenge program. And my role is also to mobilize the youth and just to make sure that the process of helping the youth is smooth. So my background is also in communications. I did journalism, and I decided to apply for this internship because I love mentorship and making somebody become a better place or become the best version of themselves. And I also love challenges, and because it's an engineering background and I am not quite versed in it, I said, let me challenge myself and learn. And truth is, I'm really learning. I'm enjoying everything. And even me, Arduino Day is a learning day for me. And I'm excited. Welcome. And fun fact about me is, I think I'm the shortest of all my friends. Yeah,
Nice.
that's it.
Yeah, thank you, Millicent. I like that phrase. Arduino Day is a learning day. Every day should be a learning day, but yeah, today it's also a big learning day as well. So yeah, thank you. That's the team, and we have more team members who were not able to join us. We have team from Sierra Leone. I think it's still early over there, but you can go on our website and check out about like the work we do and also the other team members. So before I move on, let me share my screen again. I'd like for us to do a stretch before I move on, because we've been talking. So we'll do like a short stretch. I call it the coconut stretch. So if you can find some space to move, Kiasi. I see. So we're going to spell coconut with our arms or with our body, the top half of our body. So, okay. So what's the first letter of a coconut? C. Okay, so we do C like this. How do you spell this coconut? Okay, anyway, C, yeah, and hold
Which
that stretch.
direction, left or right?
Any direction you feel comfortable. Okay, so we're spelling coconut. C, okay, hold that in. So, next one is O. Okay, O is, yeah, try and make your arms like a perfect circle if you can. O, you can stretch. Okay, and then we have another C. So it's good we have two C's. So now you can go the opposite direction. And then we have U. I don't know if you can still hear me. U is like that.
I can hear you.
Ah, nice. Hey, Agape, I'm stretch. Stretch. Stand up and stretch, Cassie. Okay. Shake it off, Cassie. So Mifka, you, the next is N. N stuff as much. Oh, like this. You can put your head down, kid. The small letter N. Coconut. Hey, coconut misspelled Vibra. Because I couldn't have you. Before. But anyway, we can go with the U again. And then the last word is T. Yeah, and that's a T. Poleni, can tell the spell coconut in a while.
Oh my God.
Nice. Okay, so we'll continue. Let me just switch gears here. Oh, sorry. Yeah, today we're guided for Arduino Day. And before I move ahead, I know maybe some of you have interacted or they know about what Arduino is, but for those who it's their very first time, I'd like to just go over the basics and I have that question over there asking like, what is Arduino? Okay, so for the ones who've been able to interact with the platform, interact with the platform, can you just like type on the chat box, like what do you, when you hear Arduino, when you see it, what comes into your head? Or what is Arduino, basically? If no one goes to the chat box, I'll just give the answer, but it would be great if people can just share what comes into their mind when they hear the word Arduino. Trying to look for the chat. Oh, no one's typing. I hope people are typing. You can guess. Yeah, you can guess. I mean, it's as Millicent mentioned, today is a learning day, so there's nothing wrong in sharing like what you know. No one's typing. Okay, that's fine. Nice. Thank you. So we have Dan. It's a way to build electronic devices. Nice. Great. Thank you, Dan. Thank you for that response. Anyone else?
We also have Brian Cave. He
I missed
says,
Brian. Yeah. Go ahead.
open source electronic prototyping platform.
Oh, nice. Hey, open source electronic. Hey, that's someone that knows what an Arduino is. Yeah, thank you. Those are great responses. Yeah. So let's go with those two for now. Open source electronic prototyping platform, and it's a way to build electronic devices. Great. Thank you so much, Keith and Dan. Those are great responses. So to move on, I'll get the definition of what is an Arduino from Arduino themselves. Sorry. Yeah. So Arduino is an open source platform, keyword open source, used for building electronics projects. And the Arduino consists both of a physical programmable circuit board, which is also known as a microcontroller. So if in the screen you can see where I'm circling, yeah, that's the microcontroller, that's part of it. And it's also the software piece, which is called the Integrated Development Environment, or IDE. And you can't see the IDE for now, but that's what the ladies are staring at on the screen. And the IDE runs on the computer, it's a software, and it's used to write and upload computer code to the physical board, which is microcontroller. Okay. I'll share a bit about like what Arduino personally for me is. As I mentioned before, I don't have like a technical engineering background, but Arduino, when I interacted with it 4 years ago through the organization, it really showed me the powerful ability of learning, especially when you have the right set of tools and a great community to support you through your learning. So for me, it has made like learning about some of the science concepts I learned earlier in school or engineering concept that I learned in physics much easier. And I compare it usually to like a geometrical set. In Kenya, we have like these geometrical sets that have like different types of tools which can help you like draw and do different like geometry calculations. And for me, Arduino is like an upgraded version of that, where you can learn so much about like STEM through the kit, and also it enables you to prototype. So it has mystified a lot of concepts in engineering and electrical sciences for me. So I'm grateful for like this platform. And also another part of the platform which is big is the open source. okay? And I'll just go right ahead and share like what open source is, because it might be a new word for them. So open source is a type of a licensing agreement that allows users to freely modify a work, use, say, work in new ways. I think there's someone in the background speaking. If someone can help me. Thank you. Open source is a type of licensing agreement that allows users to freely modify a work, use said work in new ways, integrate the work into a larger project, or derive a new work based on the original. And for me, this is the big part also, like about what we do. And GMIN is about like collaboration and being able to share information, knowledge, and improve on each other's ideas, projects, and also being part of a learning community, which is something big about Arduino. Let me just close the chat. Yeah, so for today, the theme of the day is, so as GMIN, we've celebrated this Arduino Day for, I think, 4 years, since 2017. Then they're always with different themes. For this year, the theme is undistancing, open makes us close. And this is a phrase that embodies the power of the open source community, which I've shared the definition before, and to shorten the physical distance through new opportunities to collaborate, innovate, and get virtually closer. This conveys also the power of Arduino, the users to unite at a time when it's needed more than ever. The open makes us close represents the ability of our community to transform a button into a chance to connect, collaborate, and create as one. It's also a call to shorten as many distance as possible and to explore new ideas and technologies together. And this represents an ability for community to transform. Like I remember last year, most of our programs, we ran them like in camps in person. And when lockdown or certain measures were put in place by government for people not to publicly meet, we had to like really think about like how we can run our programs, and technology played a big part. And even just like today, we're able to celebrate this day virtually, even though it would been great to have a meetup and meet everyone in person. But it also just shows like there's still great opportunities to innovate, especially using technology. Oh, sorry, let me just, okay. So how has GMIN used the Arduino platform? Through Arduino's open source platform, GMIN has been able to design contextualized curriculum for high school age youth to learn both technical skills, so the coding, the engineering concepts, and also skills that I would like to call the power skills. So these are creativity, collaboration, communication, and critical thinking. And from the photos, you can see this is a setup at a community center called Kivuli. And this is usually how we run our after-school programs for the neighboring schools around the community. And you can see just from that, it doesn't look like a regular classroom. It's really big on like collaborating with each other. And then we have workbooks that a great inlet team, the whole team at GMIN has been able to design. So, and also students get a laptop. They get to share a laptop, which we also provide. And yeah, it's really about like really collaborating and seeing like how we can learn together. And I think this model should be used in school for everything that we learn. I think the school, especially in system in Kenya, is about competition and just everyone doing their best by themselves. I think like we should have more like collaboration and helping each other, which I don't doubt like it happens, but I think we should encourage it more. So over through that, we've been able to reach around 700 plus students, and they've received introductory engineering concepts through our in-lab program using the Arduino platform. A bit of the stories I would like to highlight from this about projects that have been started by the students we've worked with. And the first project I'd like to share is from team members, let me just get their name, Brian Mwendwa and James Musau, and they're from a school called St. Martin's. They're from a school called St. Martin's Katunzweni in Makueni County, and their project was identified a project in water and sanitation, and they came to GMIN and they won the innovation challenge as one of the winners for the innovation challenge because they had a project where they wanted to design or prototype a filtration system that aims to reduce pollution in rivers caused by industrial disposal. Through our program and in-challenge program, they were able to get mentorship, and they benefited from our camp in learning how to prototype with an Arduino, and went on to win the Science for Development Award last year at the Young Scientist Kenya exhibition, which was presided over by the President of Kenya. The next team I would like to highlight, and actually one of the, it's called, the project is called the IoT-based Smart Vigilance System, and the team members are Keith Bryan, Philip Oyo, and Maxwell Okot. Actually Keith Bryan is part of the panel for today, and they're from a school called Kanga High School in Migori County, and they identified a project in security, and they wanted to create a system that utilizes the IoT technology to monitor users' homes and alert them when their house has like an intrusion that they were not anticipating. So the application is also can be installed in the phone, and they were able to prototype their solution, and they were able to apply for Young Scientists Kenya as well, and they won the overall. They were the overall best winners for the Young Scientists Kenya Award, and this offered them an opportunity to also go compete in Ireland. I think when things are much less hectic, they will be able to participate in the Young Scientist in Ireland, and they also secured a scholarship to Strathmore University. So this just shows a bit of the highlight of like what our young students have been able to do through learning through the Arduino platform. That my presentation is almost over, but I'll just say thank you again for joining us. Please follow us on social media. I'll also be interacting over there. I'm usually really loud on Twitter, but also on Instagram. You can find the organization there, and also Facebook. Yeah, so give us a like, follow us, and continue interacting with us through the hashtag ArduinoD21. Thank you all again, and hope you all have a great rest of the day. I'll stop sharing my screen, and Wango, you can take over now.
Thank you, Richie, for taking us through the first part of this event. So I hope now you're ready to meet our panelists. So I'll give it to Brenda.
We take a short break before we introduce the panel. I feel like people need to grab some coffee. Those who are waking up at 3 a.m. Do we take a break?
Okay, maybe just a 2-minute break as we play one of our Jimin videos. Maybe the video that expounds on the Innovation Lab.
Okay. Okay, everyone, you can grab a short break, and then we'll be back in 2 minutes.
InLab is a space or a platform that offers resources for youth to learn about technology and innovation. We have the students work together collaboratively in different projects, and we get them to communicate and present their ideas and their projects to their parents, their teachers, and their peers.
My experience at the InLab was amazing because I learned to do a lot of things, both electrical and coding. I even gained some skills like working with different people, different personalities and attitudes.
As a parent, we've been looking for places and actually trying to train our children after high school. But with the program here, I can sense that it's going to at least build them.
I've had a change even in our classes. They are able to solve the classwork problems, especially problems related to science subjects.
I believe that the world today depends upon young people to bring change in the areas of economic development, healthcare, security, transport, and communication. And therefore, the Innovation Lab creates this golden opportunity for youths to acquire the relevant knowledge and skills vital for this change.
My role as InLab facilitator is to create an enabling environment, or rather a place where students create, communicate, and collaborate with each other. And again, is to try to give the student a responsibility to create their own learning.
Not only do we give our students a platform to learn more about technology, but we seek to instill curiosity in them and encourage them to explore more.
3 years ago, before the program was enrolled in our school, we used to have very few students making it to university. But for the past 3 years, we've had an increase.
I will recommend InLab to others because at InLab you experience a lot. You get to showcase your talent. You get to play with things. It is compared to school, it is more fun.
InLab is fun. It's not all about the theories like in classes. There we do practicals and do the right thing.
Innovation is valuable to the youth because it enables them to think outside the box to solve their own problems. We instill the confidence in them. You know, when with an innovative mind, you're able to instill that confidence in yourself to be the change that you want to see, to be the problem solver or the maker that you want to see in society.
Okay, welcome back. I hope you were able to learn something from the, InLab video. You've seen some of the people in the call and some who are not here, but that is how much fun, learning Arduino in class is. When COVID is over, we hope to go back to that. So in this next session, we're going to do our panel discussion. Go ahead and share my screen. I hope you are able to see my screen and you can hear me well. So our panelists today are awesome people working in the industry. Some are educators, some are students, and some are in research. And the reason why we decided to host this panel discussion is to, again, talk about distancing, which is our theme for today, and how open source is contributing to learning and making as a whole in education, in the industry, and all. So our panelists today are Stephen Gitahi from IoT, is an IoT research coordinator at iLab. Then Dorcas works at Gearbox. Felicity, who is a Jimin mentor, we celebrate you, and also a product manager at Africa's Talking, and Keith Bryan, who is an alumni. I think we saw him in the Rich's presentation. So I'll go ahead and read their bios just to help you get to understand who they are. And if you want to reach out to them regarding the work that they do, you can reach out to us so that we can link you. So I'll start with Felicity. Felicity is an electrical and communications engineer from Kenya, well-versed in digital fabrication, Internet of Things system development, and embedded system design and implementation. She's currently the product manager for IoT at Africa's Talking. She has worked in rapid prototyping labs named Fab Labs and been involved in design, fabrication of systems and machines of different types. She's also a certified digital fabrication guru and is involved in training other people on how to use CNC machines to rapidly prototype their innovations before taking them to the consumer market. She has also been certified on undertaking a design sprint training called Idea to Market training, which involves knowing how to use CAFCR and Scrum Agile team techniques to build products that are scalable and robust. And she's also trained as a solar PV design and installation up to tier 3. And she's a community lead in artificial intelligence community called AI Saturdays Nairobi Study Group. So you can see like a very, very broad range of expertise from Felicity. If you want to learn more about what she does, definitely feel free to reach out. Then our second panelist today is Stephen Gitahi. He's the current research coordinator in the IoT Research Lab at iLab Africa, which I think is inside of Strathmore University. It's iLab Research and Innovation Center focusing on IoT, wireless networks, and big data. He's a technology enthusiast who loves spending time developing IT solutions. I hope we'll get to talk about those solutions. He's worked in research areas of Internet of Things and has pushed for the use of sustainable technology in improving processes and efficiency in solutions to human-related problems, especially in Africa, using embedded systems. Stephen leads the current team that is working on environmental monitoring on aspects such as water leakage, water quality, and air quality in Nairobi, amongst other projects. So you can see people trying to solve community problems, which at Jimin we value so much. Then we have our very own Brian Keith. He's a teen technologist currently in Form 3 at Kanga High School. Keith comes from a background which experiences societal changes, which sparked his interest in innovation and change making. He aims to create sustainable solutions through the power of STEM and knowledge of SDGs. STEM is science, technology, engineering, mathematics, SDGs, sustainable development goals. He is interested in the fields of open source, prototyping, Internet of Things, artificial intelligence, and Android development. His drive for innovation landed him to innovation platforms, not only limited to Innovate Kenya, the April 2020 cohort, and Young Scientist Kenya, where Keith was crowned the Young Scientist of the Year 2020. And Keith is driven by purpose and passion to mentor more teens and young change makers into STEM. So we hope the conversation today will help you, get closer to that goal. Dorcas Litunya Anono is a passionate problem solver who firmly believes in sustainable solutions for a better world through everything tech. Her key interests are in quality STEM education, artificial intelligence, mentoring, and IoT. She's currently a student intern at Gearbox Kenya, and she hopes to be part of the team that will make Kenya the Silicon Valley of Africa. She's also a master trainer at Youth for Technology, an organization that trains youth and children on programming skills. Here she has trained over 100 children and helped them develop critical thinking skills through child technologies such as Scratch. She's also a Technovation Challenge mentor, whereby she trains high school girls on building mobile applications to solve problems in their community. Her team was recently selected as a semi-finalist in the Technovation Challenge 2020, emerging as one of the best teams in Kenya. She's currently a student pursuing bachelor's degree in electrical and electronics engineering at Jomo Kenyatta University of Agriculture and Technology, and she spends her free time building websites for fun and taking nature walks. So guys, welcome to today's panel, and I really look forward to this conversation. So I'll ask the panelists where you are, as if you speak, you could just proceed and switch on your video so that we can see who is talking to us. But definitely if you have a problem with bandwidth, we'll excuse you, but we'd really love to see you while you speak. So to get us started, we know today's theme is on distancing and how open source is making us close. So, and our main tool of discussion is Arduino, given we are celebrating Arduino Day. So I'd hear from each of the panelists, what is your general experience with Arduino? Like, when did you first experience it? How was it? Did it serve the purpose that you intended it would? So we can start with Felicity, then Brian, then Steve, then Dorcas. Maybe you can just briefly talk about your experience with Arduino and open source in general.
Hi, Brenda, thank you. So I would say my experience with Arduino started after campus. So was me, I think I went to campus a little earlier than most of the guys. And at that time, there were no microcontrollers. You had to import like most of the microcontrollers. Arduino was new in the market, and the learning curve was a lot steeper. And accessing just electronic materials for your practicals was very difficult. And that's when Arduino had just come in the market, and I got myself a kit. It was still affordable. It was like 6,000 shillings. And at that time, it was more like I've understood all my university education. I'm very interested in going deeper in the electronics area and be able to build projects and test ideas. and that's when I was able to do that. Well, because I already had an engineering background and electronic background, learning Arduino was a breeze. I think I learned it in like 2 days. I'd figured everything about Arduino. So
Wow.
because I already had the background in programming, I already had the background in electronics. So it was just basically putting the pieces together. So it was pretty interesting how something could be really simplified. And I really like the fact that it could really make electronic skills very accessible, and you do not have to struggle so much to get into electronics. And from experience, I know how difficult it can be to understand those ideas. So it has made it very high level. That was my experience. Yeah.
Thank you for sharing that. Brian?
Oh, hello. Good morning. Kay. So, as a teen, since my childhood, I liked interacting with electronic gadgets, and that really inspired me. And so, when I was in high school, I first came across Arduino, and I had background in programming too. So, Arduino gave me a solid launching point into programming and understanding some of the electronic concepts were being taught in school. So having worked with Arduino, it has enabled me to be creative more enough to develop some crazy solutions, some systems which I termed them crazy. Yeah, so that's my general experience with Arduino.
Awesome. Next, you can hear from Steve and then Dorcas.
All right, thank you, Brenda. So Steve is my name, and going directly to the question, what do you actually enjoy watching it? So my background is in software engineering, but at a certain point, I think third year or something like that, I couldn't feel the touch, that the excitement that you get when you're working the right thing. Couldn't get that, and then I actually asked myself, in my room, I have these drawers that are full of wires, electronics, and just like one of the panels here. Just like I need to find a way of connecting the software to practical things, and that's where Arduino came. And just like I think I also bought my first set, and I found it very interesting, easy to learn, and I think that's like a major plus with Arduino. Very easy to learn, and so far the experience has been very, very okay. Yeah. So,
Awesome. Thank you. Thank you for sharing that. I keep hearing it's easy to learn, and I hope by the end of today, someone who doesn't know about Arduino will have learned something about Arduino and built a project. Next, you can hear from Anono. Then I can move on to other questions.
Okay, hello everyone.
Hi.
I'm sorry, I have a low bandwidth, so I cannot be able to join by video, but I think my photo should be displaying. On good days, I look like that. So yes, exactly like that.
Yeah, we can clearly see your photo.
Yeah. So my experience with Arduino was I started using Arduino last year. When we once bought it in school, so we're just doing small projects on just normal projects, small projects, just experimenting with Arduino. And the main reason I got interested in Arduino was because I was really passionate about software development. So I had done a lot of programming with regards to web development and data development, but now I wanted to integrate what I knew with software to hardware. So the best option that I had was Arduino. So basically, learning Arduino for me was not hard because I had a very strong background in. I'm not saying that you need a strong background to learn Arduino, but I picked it up fairly quickly because I understood some of the programming concept, and now just linking together, just doing projects with it was not very hard. So far, I've been able to do, like, my experience with it has been very fun and very intriguing, just trying things out and seeing if they work or not, and just solving problems along the way.
Awesome. Thank you so much. So it seems like Arduino is really simple for everyone who's spoken so far. And like I said, I hope we get to build some projects so that we really test if it's easy to learn. And also one thing I got is the integration between software and hardware. How do you get to write software to implement something and then make it practical so that you can translate it to your hardware? So I think that is one thing that has really come out when you're trying to integrate, build different hardware and try to use software to operate them. Arduino could be a really nice tool to do that. So the next thing, I want to again refocus on the theme, which is undistancing, and how open source is bringing us together, even at a time when we are trying to keep social distances, we are trying to stay away from each other. But then, how are these open source platforms enabling us to connect, to continue working and building wherever we are? So my second question would just be on what is your take on open source? Not necessarily Arduino, like open source at large. How has it contributed maybe to your learning or even in your building Arduino projects? Do you think it was easier maybe because of open source, or did you experience any challenges because it's open source? So I'd want to hear just and this time I'll pick a different order. Maybe you can start with Brian, and then Dorcas, and then Stephen, and then Felicity. So your general view of open source, not necessarily linked to Arduino, but you can link it to Arduino. Brian, you can go ahead. Do you still have Brian? Yes, I can see you. If you're speaking, you're muted. Keith. If Keith is not ready yet, maybe you can hear from Dorcas, then Stephen.
Okay, so for me personally, open source is very important generally because most of the software that is open source is normally free to use. So that makes it accessible to everyone and most people, because you can imagine paying for a software would limit how accessible it is. It also helps, especially in terms of development, contributing to open source software, like when you're able to just do code and push and collaborate with different people from all over the world. And it helps to, like, if you have a problem and you feel that you can fix it with a software that you're using, open source is really flexible with that, because you can just try to modify the code to, and then if it's approved, your software, the software now solves that problem. So it's basically like scratching your own itch. So it's very important. And I'd say open source helps you to learn also, because there are many programs geared towards contributing to open source software. For example, I think it's called Google Summer of Code, that whereby you just contribute to different companies that have open source software, allow students and people to contribute to that software, and you get credit for that, and you can say that I contributed to this software, etc, etc. So open source is it's very important and very very.
Okay. Thank you. Stephen, maybe your thought on open source?
Yeah, thank you, Brenda. Well, I'll also take the same approach as okay, open source has more advantages than disadvantages compared to in terms of advantages and disadvantages. So again, going back to your question in terms of distance, what open source allows and what it's supposed majorly is the development of the community around a certain subject. So if it's Arduino we're talking about, then you have different people doing Arduino, different people tinkering with these devices around Arduino controllers, with different sensors, with different actuators around that specific controller. These people can share the knowledge they get from each other, they can share the experience, they can share the problems they face, just like Kate mentioned. You can share different problems that we face. I can tell you, so Brenda, you're facing this, how you feel about it. So not only problem, but also development, growth as a community, growth as a person in terms of skills. So what Arduino has done is by making these devices available, by making the software available as an open source, is growth. So you can take an Arduino microcontroller and think about it, understand how it works, and if it does not have something that you like, for example, I would like my Arduino board to have Bluetooth connection, I can go ahead and use the information they provided about the board, add an extra Bluetooth module on top of it, and produce that as a new board. So you have a product that is growing, not necessarily from the company, but from the community. So open source is great in terms of growth, in terms of development, and it is from that angle that people are able to do more projects that have more capacity. Now want to add Bluetooth, it's very easy for you to just take it and add that chip, have it working, and explore the different things that you'd like to do. So growth is very important, and it's being brought about by this aspect of solution problems out there. But also, innovation and competition comes as another other outputs of these being available, things being available. And we've seen even in Kenya, to bring some sort of perspective, the Kenyan government does not type to different technologies. So that way people are able to explore and produce even better solutions. I think that's pretty much summarizes.
Thank you for sharing that, like so much knowledge and some of the things that I've already heard from Dorcas and Steve. It's, there's growth, there's people to help you, you're building together with the community. If you experience challenges, there's, solutions out there for you. Felicity, do you have anything to add regarding open source?
Yeah, I thought because most people have really illustrated the way open source makes learning accessible and how we're able to problem solve and do it ourselves. I thought I should give a practical demo of how open source has impacted some of my learning journey and growing. So this is a board we built. This is an Arduino that you can make yourself. So I don't know if it's clear. This one, we built it in a lab ourselves. So the fact that Arduino is open source, it means you can download it. You can build your own Arduino and you get sued. And then you can improve on it. So you build it, then you add maybe one or two things depending on your level of knowledge. So I think that's just a practical demonstration of open source. It's when you make it open, first of all, you allow the community to make it grow. So you can have your own interpretation of it. You look at something and you're able to think, I can add this and make it better. So it's very good for people who are either building things for learning and for fun, just to grow. When it comes to, as a person who is in the industry, when it comes to now when you want to build things for the markets, it might be a little challenge. There's some open source tools that you can use, but there's some open source tools that might be dangerous to use. So it's like a two-edged sword. There's some things, if you use them, your system may not be so secure. So it's very important that if, for example, you grow to a point where you want to build things for production or to go out in the market, examine your technology very well and find out whether there are loopholes and there might be risks implicated. But while you're learning and growing, it's very good.
Awesome. And I think I really like that thing you've brought out about even the hardware. And I think even Steve touched on this. You can modify it the way we want. And I know most of the times when we talk about open source, our minds go to the software only. But yes, we've seen a very good practical example from Felicity, what she was able to modify and build their own board, which you can use to develop. And I don't know, maybe Kelvin is not yet in the call, but an organization like TME Education, and they they create their own boards and modify the Arduino to fit learning institutions' needs. And also, we've seen people being able to produce it at large scale so that you can distribute it across. And now I think it's even more affordable at about 4,000 shillings, you can get a kit. And I think I really like the way you've touched on the growth and the building community together. And Kate, I think you left the call for a minute.
Oh, yeah, sure.
Yeah, so we're just discussing, the experience with open source and how Arduino is contributing to open source. If you want to say something, you can say something briefly before I move on to the next question.
Okay, so my understanding of open source is something which is they are available for free and one can modify it. So Arduino, being user-friendly, has demonstrated that it can be used by anyone who is interested, such be it a programmer, kids, or electronic enthusiast or hobbyist, to develop local solutions. And also the Arduino IDE software enables them to write codes and upload them to the board in order to make their systems. And also experienced circuit designers can also make their own module by modifying or extending the existing version. Thank you.
Yeah, thank you for sharing that. We definitely agree with all those things you've mentioned. So before I go to the next question, I see Richie has shared here. Yeah, follow us on Twitter. If you want to follow the work we do at GMIN, you can follow at Global Minimum. We have at Innovate Kenya, and we have also Instagram, global_min, _. And on Facebook, we have Global Minimum, Innovate Kenya, and Innovate Kenya Community. So all these platforms, we try to engage youth there. So sometimes we post student stories of projects they're building, things they're working on. And if you want to email us directly, you can send us an email at info@gmin.org, and someone will definitely be there to answer your questions or to attend to your needs. So my next question, and after this question, I'd encourage people from the audience, if you have any questions for the panelists regarding Arduino, they're the experts, you can type into the chat, and Doreen is here. She will read out for me, and we'll maybe have some of the panelists answer the questions. So you can type them as we proceed. And my next question is about education. As GMIN, yes, we try use technology to make education fun for kids, and you've seen Felicity has been one of our mentors, and it's usually very exciting to see like the work she's able to achieve with the kids. Sometimes something looks so out there and like really far to reach, but she has been able to build those projects, prototypes with Arduino. So maybe from an educator's point of view, and Kate, you are a student, Stephen, you work in research, and Dorcas, you are a student, and also at Gearbox, you're doing very many educational products and programs. So I want to hear what do you think is the role of Arduino in education? So as a tool which we use in class, what do you think is its role? And maybe you can just give a comment of how you think it could be useful or not, if you think so. So we can start with Brian. You can give maybe your experience as a student, and then Stephen, and then we'll go to Dorcas, and then Felicity.
Okay, so let me begin with my experience. Since just like I had mentioned that since I was young, I was interested in electronics and fascinated about it. So Arduino has definitely given me a hands-on practical skills and a working knowledge of dealing with electronics. And also, it has also led me to, I've loved physics because of Arduino. Arduino has led me to love physics and as a subject. And also, Arduino has given me a solid launching point and yet a working knowledge of programming, understanding the logic behind its principles.
Oh, that's a very good observation. And for those who are in the call earlier, I think one of the videos we played from a school that we work with, one of the teachers was saying before their students started attending in-lab where they were introduced to Arduino, people never, like, they never made the, the pass mark to university. People didn't want to study physics. But the moment they were introduced to Arduino, we even had students going to beg their teachers, they want to change the subjects because now they want to do physics. So I think I like that idea of, sparking the interest in science and, making it practical so that people can understand better. Next, we can have Stephen and then Dorcas.
Okay, thank you. Thank you, Brenda, for the question. Well, Arduino has played a very great, among other, call them embedded system in us. And just bringing this back again to Kenya, with the kind of, look at how many achievements are out there, growth that has sparked. It's very good. And it tells you the role of these hands-on skills, building capacity among students. And also, there are questions about digital divide, how humans help seal that, because now students are able to prototype this from a very, very low level to advanced solutions. So, for example, what we've seen with our friend who won the international competition, and now they've won an opportunity to come to Strathmore. Now, just to mention, the same Strathmore is where we are located. There we have a very advanced IoT, which means with his solution, it can be built into a commercially viable solution that can be put out there. And with the help of partners like Felicity and her team, we're able to push this further. And I think the government even has also seen the need for this with the introduction of CBC, competence-based curriculum, to help move this. And again, for personal development, you're out there, you can build a solution before you even get to campus and even graduate and get a job. You can build a solution that you can build a company from, because now you have the capacity, you have the experience that you need, and you can actually employ yourself. So these are problems like lack of employment in Kenya now are being sorted in such ways, and it's because of the availability again of such platforms like Arduino that we're able to do this. I think just before I give people the platform, so part of my projects I've done a few projects I think I had mentioned in the bio, and I've seen the need to actually work with people who are out there trying out these things. So it's easier to even source for projects to get in terms of capacity, people who actually know how to think about these things. In the past, it was a problem getting someone who knows how to work controllers, sensors, the different devices like what Felicity has shown. But now it's easier because people are taking up this. And I would encourage you to actually take them up, because these skills we're able to do more, and both at a personal and even at a country level. And I have to thank you, for what you do in terms of building this capacity in education.
Thank you for that, Stephen. And I really like the way you tied in, youth and employment, and how people can actually use Arduino, learn the skill, get, to work on a project that's using Arduino. And people who are interested in Internet of Things, that's like a very good place to start. Build your skills so that in future you are employable and things like that. Next, you can hear from Dorcas.
Hello, you can hear me? Yeah?
Yes.
Okay, so personally, I feel like education, like learning Arduino, the basic thing it teaches you is problem solving skills. Like, if there's nothing else it teaches you, just teaches you problem solving skills. Because like when you get stuck at a bug, you know that, okay, how can I go back and like look at what I'm doing? And like it teaches you to break down a very complex problem into smaller bits that are more solvable. So when you see this, like when you teach someone how to solve a problem, they don't want to solve the next one and the next one and the next one. So as you're solving more advanced projects or problems, you're learning and you're learning. So it opens up your mind to the mindset that you can be able to do anything, and when you see it, you can become, so like you start doing the projects better, and like it just helps you to develop that mindset in education, and you can be able to learn more and become a better problem solver. So it's very key. And even as who talked, I think Steven, no, Brenda, you talked about it, like when you educate especially the young generations, like the children, on such skills, they start getting an interest in STEM. You can find that especially when you go to, let's say, marginalized school, they never knew that, like they never knew who an engineer is, they never knew like what STEM is actually. So like they're very limited to the career choices they have. So once they start seeing people that are undertaking these careers, they start seeing how like my education ties to this career, they start getting motivated to pursue such related courses. So it's very important to just open the mind and to solve problems, because like there are endless problems in the world, but now just being able to solve them using technology is good.
Thank you for that, Dorcas. And I see even Doreen has said in the chat, like, I love that indeed problem solving is key. And that even brings us to one of the pedagogies we use at GMIN is called project-based learning. And for example, our in-lab students, they have, as they are learning Arduino, they have to build a project using the Arduino that is solving a problem in their community. And it was surprising that, students were able to prototype like smart greenhouses to produce more food in their schools. People are trying to build robotic solutions for cleaning, for just making their classrooms better. So I really think it's important to remember that being able to solve a problem. So the technology, Arduino as a tool, is available to help you innovate. But yeah, really you're getting to solve problems. Thank you for sharing that. I think we can hear from Felicity, and then after that, from the audience, if you have any questions, I'll be welcoming you to ask them. So you can raise your hand. Felicity, you can go ahead.
Yeah, so looking at Arduino from how it impacts education, for me, I'd look at it how it has evolved from when I was a student and to when I was like learning, to when I was building projects, to mentoring, and to being a trainer and being in the industry. I'd say, like, from a learning perspective, you have to chart your learning. You have to be intentional about what kind of growth you want in your learning. So what I'd say is that you have to be careful that you do not stagnate in your growth of Arduino. So because as an entry-level person, it's okay to pick other people's projects and modify. The next level would mean that you have to build. You have to be the one contributing information for other people to pick up on. And you also have to think about, like, do I want to grow to a level that I can also customize an Arduino and build a project that can be deployed and things like those. So you have to start from where you are, but think about the big picture, like, where do I want to be in the end? Who do I want to be in the end? As an individual, that's a very good vision to have. So, and then, so that much as a lot of open information is there, much as a lot of people have built upon it, you do not become a person who is dependent on what other people have built. You're also still able to think creatively around the solution. So I'd say it's very good. It's very good in terms of starting out. Your growth is going to be determined by you understanding where you want to go. Otherwise, you can find yourself just tinkering around at the same level and playing around with other people's codes and not being able to create your own. So you have to be very careful when you're dealing with even a lot of open source technology, because a lot of people have built those projects, and what people do is that they copy and paste. So you find people copy and paste. And then another thing I wanted to note also, still, if you want to now take your whatever growth you've done, and then you want to grow it in terms of an enterprise. So I want to build a solution that I can sell to the market. Of course, then you have to think about which is the best way to do it because when something is open source, you still cannot use it for commercial purposes. So you have to find a way to not to still not do the copyright thing where you just take what's already there and put it out there. So I thought I should note that.
Thank you so much. Those are really, really important points, and I definitely agree. Like creating a plan so that you know how much you want to grow, things you want to do. So what happens if you want to build a system and there's no code online? That's no person has done that project before. So you should be ready to initiate that process and use the knowledge to create your own code and share. And that in a way you're also contributing to the open source community because someone else will get to benefit. And I like the whole idea you brought on entrepreneurship, like you're trying to build a business out of this. And a good example is I think AB3D, they build 3D printers, and I know it's based on the Arduino Omega. So they did modify the hardware and the software to fit the model for the 3D printers they were designing. And yes, they are able to train people and charge them a fee or resell, directly sell their printers to schools, to people who are trying to 3D print stuff. So that's a very good a good thing you've highlighted, Felicity. I see Mr. Kelly saying, apart from initiating problem solving, it also broadens the learner's thinking capacity. I like to hear that because I know at your school you've been, tinkering around with the Arduino, and I think this is a good observation, and we hope the students continue learning from it. Yeah. So at this point, I would like to invite a question from the audience before I conclude my panel discussion. If anyone wants to ask, you can go ahead and mute yourself and ask, and then I'll ask the panelists to answer.
Hello.
Yes, I can hear you.
How are you people?
We're doing great. You can go ahead and ask your question. Thank you for joining us.
Thank you. I don't really have a question. It's much more of a compliment.
Mm-hmm.
I have had some great students. For example, this guy called this guy from Kanga High School. Is it Brian or Kate?
Yes, Kate Brian. That's both his names.
Kate Brian. Kate Brian is a young guy, probably the same age with the guys that I deal with at school, but his understanding of these things is just so much interesting. I wanted to ask, how did Kate Brian get to that level? Maybe I'm still new in this program. I do not know all the processes that Kate Brian has been inducted through, but if we can get our students to the level where Kate Brian is, if we can inspire our students, I've seen the likes of Sandra Konya. If we can inspire the likes of Sandra Konya so that they can reach the level where Kate Brian is, to be able to explain the problems that his society is facing using the little provision that he has, I think we shall be doing something excellent. And secondly, and lastly, probably, I've been trying to do this thing with some of my students, but gradually you start seeing students, they get out of their comfort zone. Gradually, they start thinking critically about the problems that they are facing. Initially, we had students who are thinking of projects which they had just borrowed from somewhere else, right? But recently, I have seen students trying to localize problem, to find problems within their environment, and possibly try and think of a global solution to their local problem. You get me?
Yeah.
To me, that has been an eye-opener. Students finding a local problem and trying to use the available resources to look for a global solution to the problem that they are facing.
That is awesome.
That has been great. That has been a great experience.
Okay. So thank you. I think I lost Mr. Kelly for at the very end. But I think, Brian, since you're in the call, you can directly answer, like, how did you get there? And I see Sandra in the call. I hope you're listening to the tips on how to really become efficient at using Arduino, so that maybe you can, enable that culture in your school. So Brian, you can, Keith, Brian, you can quickly answer that. Like, what are some of the tips and things you did to make sure you're getting better at using the Arduino? And then I see there's a question on what's been the hardest thing in learning the Arduino platform. I think Stephen, you can help us with that. And then Dorcas, you can go through Brian Kimathi's question. What are the basic steps of learning Arduino, especially to high school students? Though I think Keith Brian might handle some of part of that. And Doreen, you are raising your question. So after we answer, you are raising your hand. After we answer these questions, maybe you can go ahead and ask your question. So Brian, you can go ahead. How did you get there? Then Stephen, you can say what was hardest about Arduino.
Oh, okay, thank you. So my journey in innovation began in IJ Kanga High School. So where there were students who represented the school in US, and also I wanted to be there. So at the end of Form 2, at Form 2, I was able to attend a STEM workshop where I came to know about Global Minimum and Innovate Kenya program. So at the end of Form 2, I applied for the Innovate Kenya, where I had a project in security. So from Innovate Kenya, we were able to go through design thinking and mentorship clinics. And at the end of the program, it really acted as an eye-opener and really sparked my interest in innovation and technology in learning. I think that's my take.
Okay, so one thing I'm picking up from that experience is participating in activities and programs that encourage you to continue building and making. So constantly, working at it, building something and learning more. Yeah. So next we can get to hear from Stephen. What was the hardest thing when you are learning Arduino? I know you all said it's easy, but there must have been something to scare Richie.
I think we all started with it's very easy to learn. It's very easy to learn. I think the thing is, with the community, there's so much resources online to support you in terms of learning. So, Felicity bought her first kit at around 6,000 shillings. So that price might be the only thing that may be a hindrance. But again, given that the devices are open source, you do not need to buy the whole kit. That's a whole kit. You can buy one microcontroller, 700, 1,000 shillings, or 1,500 shillings, depending on the capacity. So just start with that. Start with one sensor, move with the next sensor. Stand the board. Softwares are free to download. So maybe the other question would be internet availability. But again, it might sound political, but Kenya is top 3 in terms of internet availability in Africa. So let's say the government has done its part in terms of providing this resource. So I think it's up to us to encourage more people to pick up this device. And number 2 would be working with someone. So don't work alone. Given that there's a community, just find me on YouTube, visit this team, trying to do this thing. I'll just point you to the right direction. The interns that we have around, can just hook you up with someone that you can work with, so that things that might be tough because of lack of experience are no longer tough, and you can move on to the next part. Maybe my other point would be, even in high school or campus, there are clubs around right now, STEM clubs that are pushing for innovation. So we find
I think I lost Steve for a moment there. Can anyone else hear him?
No, I lost him too.
Okay. So I think he touched a bit on also like what as a student you can do to make sure you're getting started to avoid being stuck, like learn step by step, start with one sensor, move to the next one, and grow as you learn. And I think Dorcas, maybe you can, what could you say to high school students out there? I see Brian asking, how can high school students learn? What can you say to high school students out there who want to get started with Arduino? What's the best way to just organize themselves and how do they go about it?
Hello. Everyone has talked about joining a club in school. There's so many clubs that do this, and also many competitions, Innovate Kenya, and then like the that global minimum offers. Also, if new education does this boot camp for children, and also teenagers in high school. There are programs that also they don't teach you Arduino, but they teach you how to code. So that one also can help because it will help you to understand the software of the program. So coming to just implement the hardware is not hard. Also, currently, if you don't have money for a board, there's a software online called Tinkercad that simulates a board. So you can start with that, although it will not give you like the whole experience of having a physical board. But since it's free, you can just go, and then it has like a picture of the Arduino, and then now you connect components. You can learn the basics on Tinkercad. So you don't feel like the 6,000 or the 700 is a limit factor. There are YouTube tutorials. There's one particular one I like. He's called, what is it called? Paul McWater or something like that. So there's just up. If you get any hindrances, you can ask. Like, since you're in this call, I think like most people are open to like help you, something like that. Personally, you can reach out to me or whatever. A long time. So as a high school student, just mostly that, and just trying to join clubs that help you to learn either the software bit of it through coding, or if there's a program over the holiday and like you feel like it will help you grow, attend these programs. They open your mind, they introduce you to things that you would not learn in school. Yeah, and let's say if someone has not done physics, don't worry, it's not a must for you to understand physics for you to do Arduino. Yeah, so just the hardest part is just getting started, and then you start and your path just opens up from there. Yeah.
Thank you so much. I've shared the link to Tinkercad in the chat. If anyone wants to check it out, you can follow and sign up. But thank you so much for highlighting that, because sometimes maybe you don't have the 4,000 to buy the board and your school doesn't have it. And one thing she also mentioned is, ask someone who already knows. They are always available to help you. Doreen, you're raising your hand. Do you have a question?
Thanks, Brenda. I feel like my question has been partially answered, but my main concern was, and I really like that our panelists have raised this, and some of the people in the audience have also raised it, about high school. Like, how do we invest in high school students as far as Arduino is concerned? Like, how do we nurture this? Because one thing I like about Arduino as inspires, or rather equips people with problem-solving skills. With that hands-on experience. Also, I like that. And when you look at our education system, you realize that most of it lacks the hands-on experience. And I'm glad that we have a few high school students in our audience, but then I keep asking myself, like, how many students out there are missing out on such opportunities? And how do we ensure that like such opportunities, such programs reach out to as many students as possible? Because you realize that many are lagging behind, and like, how do we ensure that we are inclusive in such things? Like, how do we nurture such skills in our high school students, ensuring that everyone is involved. Thank you.
Okay, thank you for that comment. I think I'm running out of time. I know Wango is about to tell me your time for the panel is over, but I see one final question from Freddie Munyao. And I think Felicity, maybe you can help with this one. I have an Arduino project and I would like to make it as a product available for the market. What are the legal procedures that I should follow to make it approved as safe for the customers? And I think for the safety part, you'd have to describe what it is for people to know what are the risks for your product. But maybe you can touch, Felicity, you can touch on like what procedures as a product manager, like what procedures do people follow to take a product from just a project stage to the market?
Yeah, so if right now it's in the Arduino stage, I'm assuming what you have is a proof of concept. So when you want to go with a product to market, you definitely have to think in terms of if you're using an Arduino, it might not go to a very big scale if you're taking it, and then the idea about commercializing something that's supposed to be open source, there could be a bit of a legal mix-up. So first of all, to make it safe, there's Kenya Bureau of Standards. So just getting it standardized and stamped. And right now, I know there's a commission around electronics that has been formed. And then intellectual property also. We have Kenya Intellectual Property, KIPI, I think. So that they can still help you to either have a pending, a sort of like a patent pending, or have like a full patent, because I know these processes take long. Most people do like a pending patent as they start commercializing. Then the moment you fully patented it, you're able to go full on into the market with it. So yeah, so you may need to get like a lawyer to help you through that. There's intellectual property lawyers to help you through. And yeah, and of course you have to think about your financing and everything. I can't cover every single thing of taking it to market, but these are just some of the things I can touch into. And then, of course, on the idea of that your product depends on whether it's a medical product, a commercial, like whatever standardization is done depends on what use case it has. That's what I can touch.
Thank you for that. I think that's a very good place to start. And like you say, depending on like which sector it belongs to, if it's going to affect the environment, you're definitely looking at NEMA, knowing like what licenses do you need, what tests do you need to do to make sure it's safe for the environment. If it's medical, there's KEMSA, KEPSA, all those people. So knowing where your solution lies, the category or the sector which it's affecting will help you know which authorities to approach to get approvals and things like that. So thank you so much for that explanation. Ruth, you're saying you want to learn, more about Arduino so that you can share the knowledge with other people. So yeah, the InLab team is here for you. Talk to them and see what extra help they can offer within your school so that you become experts at the Arduino. At this point, I'd like to say thank you so much, Felicity, Steven, Brian, and Dorcas for just coming to answer and be part of this conversation about open source, Arduino, and how it's helping us become better learners and problem solvers in our community. So thank you so much for taking your time. Our panel discussion ends there. I think Wango, you can let me know what next. That's it from me. Thank you so much, everyone, for participating.
I really enjoyed that panel discussion. Thank you so much to our panelists and for all those who asked different questions. So if we look at the schedule, so at this point, we will have Arduino-based demonstrations. At the moment, they are pre-recorded. So our first demo will actually be from a video by Brian Keith. And then we'll have another demonstration by one of our Jimin mentors called Kelvin. Unfortunately, he couldn't join us for this event because his organization, TME, is also hosting an Arduino Day, but he was kind enough to do a recording for us. So Brenda, you can play them for us.
All right, go ahead and play Kate's video.
Motion sensors works under the principle of radiation detection, in that when a body emitting heat crosses the path of the motion sensor, a signal is relayed to the Arduino Uno, which trigger the alarm and light system to go on simultaneously. In the meantime, a real-time SMS is sent to the user's phone, notifying him or her that the premise is under siege, and the message has got a unique IP address which can be used for the live streaming of events. As I can demonstrate, the system goes on and there's a message sent. You can either reset the system with the help of the reset button here, or send a reply to the SMS sent, simply stop. Again, from the acquired message, I'm able to live stream the event that is happening using the unique IP address obtained from the message, and we can be able to live stream. As you can see, we are able to live stream what is happening. A clear indication that the system shows what happens in your premise. You can also get still pictures. It has an option for getting still pictures. As you can see, we have a still picture of the burglars intended to.
Okay, I hope you were able to see that demo for Kate. This is the demo they gave for the 2020 YSK exhibition, and they were able to win the award with that project. So that was really good.
Few years back, only experienced.
And before we watch this video, Kelvin is the TME education ambassador for Kenya, and TME is an electronics distributing company, but they have a CSR project where they build these educational boards based on Arduino to help people across the world to learn. And Kelvin is also a former facilitator at InLab, so he's really like a close friend to the organization, and we are happy that he made this video for us.
Engineers could be able to design and build robots or automation systems. But today, with the birth of these Arduino microcontroller boards, anyone and everyone can become an innovator. My name is Kelvin Kangede, and I'm a technology enthusiast. And I'd like to wish all of you a happy Arduino Day 2021. Arduinos, these microcontroller boards, are playing a big role when it comes to enhancing our creativity, prototyping, and making science fun. Yeah, making science fun, because I believe that science needs to be fun and hands-on and practical, where you can create your own interactive object, which you can program to follow some certain commands or achieve some sort of functionality. And Arduino is all about that. I want to share a personal experience. So few days ago, I left my house. Then a couple of hours I came back, and unfortunately I realized that there was a water leakage from my water tap. So the whole house was flooded. So I had a lot of work in draining all that water. So later on, I asked myself or questioned myself, what can I create? Is there anything I can create to make sure this does not happen again? Then I discovered that I can use this water sensor with Arduino and a couple of other few components to create a system that can automatically alert me in case there's a water leakage. And you see now, that's the beauty of this Arduino technology, because these boards make anyone to be creative, and you can always create solutions to some of your problems. And some other times, even it's all about creating, fun projects. You might be wondering, what is this? So this is my latest project. This is we call it an 8x8 LED cube. Let me just connect it to the power. There we go. I love it so much. So it is made up of light emitting diodes. So you solder all of this together, then you can program it, then you can be able to achieve all these cool effects. There's a little button over here. So when I click the button, it moves on to the next button. And as you can see, for the casing, or for the casing, I used just a normal cardboard, then the spray paint. So inside this box, there's the Arduino. This is the Arduino board, which stores the memory for all these effects. Then with the pandemic, and we have to wash our hands all the time, I designed this system that you can use it to create an automatic hand washing station. So there's the sensor, call it an ultrasonic sensor, so it can detect I won't say motion, it can detect an obstacle. So you program it how many centimeters you want it to detect the obstacle. Then it activates the water pump. This is a submersible pump, so you just put it inside the water tank. Then you power on your system. So when it detects the presence of a person, then it just starts to pump the water for some few seconds. For WHO, this recommend 20 seconds. So that is what I have programmed it to do. So for this one, I'm not able to demonstrate it because it's going to spill all over the camera. Yeah. So my encouragement or my challenge to you would be just to tell you, continue innovating, make to learn and learn to make.
Wow. I hope you enjoyed the videos and you saw, some cool applications of, Arduino and things you can do to build at home, like appliances you can build at home using Arduino. So I'll take it back to you, Wango, to lead us to the next session.
Okay, so we've talked a lot about Arduino. We have seen two demonstrations on projects that have been built using Arduino. But I think now it's about time we get hands-on and build our projects. So I feel like we need like a 3-minute break. But during the break, if you have an Arduino kit with you, you can go get it. You can use those 3 minutes to just stretch, so that we can come back and build our first project. And it's okay if you do not have an Arduino kit. Even as Dorcas mentioned, there are tools online that can help you simulate how an Arduino works. So we're going to watch the in challenge video as we prepare to build our projects.
Always the same idea, which is not destroy, let your voice call only, then set turns up. It's a voice, a young woman.
from high school thought that they wanted to be part of an organization that focused on solving problems around the world. When we started doing projects in Sierra Leone, it became very clear quickly that we did not want to be always developing solutions and handing it over to people. We wanted people to think about the process of developing solutions, because that was also a learning opportunity. And we did it in Sierra Leone in 2012, and it went really well. And a couple of one of the co-founders, Jacob, was moving to Kenya, and he wanted to do it in Kenya because there were locals in Kenya who wanted this to happen. And so we naturally expanded to Kenya and did Innovate Kenya.
I'm young. I have my smartphone, and I love my iCloud. It's secure for me. Pitch why I shouldn't use my iCloud anymore and I should purchase your product.
You are passionate about your idea, but go out there, and execution implies all the above things that I've said. Testing it out with people, your friends, your families, people in the market out there. Don't be afraid. Do that.
My name is Brenda Nyakova. I'm 16 years old. I study in Makini, and I'm working with Innovate Kenya because of my project, the Skypod, which is a transport system above the roads to better everything in terms of transport. We've been having mentors that come and talk to us, and the advice and the whole consultation thing kind of helps us a lot in terms of expertise. Yeah, so we really get to learn a lot from them. Yeah.
We challenge the youth to come up with ideas, projects, solutions to some of the problems they see in their society or in their community.
My name is Michelle Ngure. I'm a program manager of the Innovation Lab at Global Minimum. So Innovate Kenya, or Innovation Challenge, is a competition-based one-week camp where we solicit applications of project ideas from students in different schools. So what we do is we encourage youth who have ideas that solve problems that they have realized that are in their communities. When these students have these project ideas, we invite them to apply for our competition. So Innovate Kenya has this one-week camp where we take the finalists from different project areas. So it could be agriculture, it could be energy, it could be transport, it could be arts and crafts. So we take them through a one-week camp, an intense one-week camp, and take them through various workshops, different leadership clinics, design thinking training, and we get them to work on their idea. And what we do at the end is that we get them to present these solutions or project ideas that they have to a vast audience. So it could be their families, their peers, and also other professionals in different areas of interest. And so what we do is just encourage them to keep thinking of how to solve issues in their communities.
And the next team was the most audacious team, and this was the Skypod team. They also received a workshop to Baringa School as well. So clap for them. It's Kenny and Vera.
The objective of the program is to actually take them through an accelerated process or a really quick process of them learning how to become change makers in the society.
I feel like I can make a change in this world, and I feel like I'm compelled to change what we have in the communities, especially the problems they face in the communities. I feel like I should go back there and work with them.
They have a wide range of expertise, including IBM, which can help you guys with your research even after the camp. So they don't leave you guys wherever you are with awards and certification. So they offer you mentorship, and they can link you to guys and companies which actually are relevant in your field. And that's really awesome. It's a plus for them.
GMIN has a network of relationships with people across the continent and in Europe and in America, where our students and our finalists can continue either developing their businesses or continue with their education. So we typically send 2-3 people to ALA, African Leadership Academy, or now African Leadership University. We have a student who's at Harvard now who was an entrepreneur for 2 years with a project that they developed. There are students who go to local universities in Sierra Leone, in Kenya, and South Africa to pursue STEM-related work. And in terms of conferences, whether it's UNICEF conferences or TED Talks, really global platforms, we also expose our students to those opportunities.
You can do anything that you set your mind to do, that no idea is ever too big or too small to develop, and you are the greatest. You are what you define yourself and not what others define you as.
Thank you. Thank you for watching that. And as you've heard, we always try to, create opportunities for our learners. So if you're in the, in the call today and you know of, or your organization gives opportunity for students to tour your workspaces, feel free to reach us so that when we host our camps, we can bring our students to your spaces to see the awesome things that you guys are building or working on. So thank you. Wango, you can take over.
Okay, so I'll begin this session, this hands-on activity session, with a poll that will appear on your screen. So just one question. I think I'll just give you like 1.5 minutes to answer. $15 more seconds, and then I'll I'll end the poll. Okay, so from the poll, 45% of us have little experience with Arduino. We have 36% who have no prior experience, and then we have 18% who are experts. So I think this particular session is mainly aimed at those with no experience to those with little experience. So the ones with little experience, I'm expecting you to participate. When I ask a question, I'm really hoping the chat will be just full of people attempting to answer. So I want to show you the project you're going to be building, a very simple project. Are you able to see?
Yes. I can see an LED, a green LED blinking.
Okay, so for this particular session, we're just going to go through how to build this particular circuit on how to blink an LED. And if you have the components with you, maybe you can switch on your video and show me your kit. If you have your kit, let's also, for those who have the physical kits, maybe you can just switch on your video, show us your kit. Nice, I see Millicent is prepared, Doreen. Okay. So if you don't have a kit, it's okay. You can just follow as I build. So we're going to start with first a simple description before we start building. What is a circuit? Somebody can say it out loud by just unmuting, or you can do it in chat, and then Doreen, you can read for me what they say.
What is a circuit? Is the path taken by an electric current.
Okay.
Current.
Thank you, Fanuel. You are right. So just think of a circuit as the path within which current flows. And the three things we need to consider is the voltage. Even from just the description, this is that thing that helps push electrons like through a circuit. And then you see the current trying to flow through the circuit. And then we have the resistance, which is measured in ohms. So Resistance is the capacity of a material to prevent the flow of current through a circuit. So we have the voltage, which is measured in volts. We have the current measured in amperes, and then we also have the resistance. So when we look at the Arduino, we have there are two main things we need to consider. There's the hardware bit, which I believe Richie mentioned at the beginning of his presentation, and also we have the software. So this is actually the what's on your screen is now the hardware bit of Arduino. So I'm just going to mention just like a few things that will be relevant for this particular workshop, but please take your time to explore more. So for those who have the physical Arduinos with you, if I mention something, try and also locate it on your physical Arduino board, okay? So I think this should be, since there are people who have little experience, I think you understand how the Arduino works. So I'm just going to mention like a part, and then you can just try and explain to us what you think it does. Let's start with the USB. We have the USB port on it. What does it do? Majority of us have little experience, so I'm sure you'll be able to answer that. Or I should start choosing randomly. Is it possible for Sendorcas Educational Center to switch on their video? If it is, I'd really appreciate that.
Dalmas, I think that it's Dalmas who is
yeah.
Dalmas, are you able to switch on your video so that we see if you guys are building, what you guys are building?
Okay, so USB guys, you're constantly charging your phones. Well, I think should I put one of my team members on the spot, or should I just choose randomly? I think I'll choose randomly. Brian Kimathi.
I have no experience with Arduino.
Wangu, I think we have responses on the chat.
Okay, please read for me. I want to be able to look at the chat for now, so you can just alert me when they come in, okay?
Yeah, so we have Kay. He says it can serve two purposes. And then Dan Murray says you can connect Arduino to your computer with a USB. And Benny says USB is used for powering the Arduino board from either a laptop or a computer. Kay says either loading calls to the board or powering the board. And then Benny also says powering on the Arduino. We have Freddie saying.
That's good. That's good.
Yeah.
Oh, so actually people were participating in the chat. Thank you for all your responses. So yes, the USB has two purposes: to power the Arduino, and also it's the place we're going to transfer our code once we have written it on the IDE, on the software. So we have also the microcontroller. Try and locate it on the picture, or if you have a physical board, try and locate it. So this is basically the brain of the Arduino. So this is what's going to be, this is what's gonna ensure that your Arduino works the way you'd like it to. Can you see some digital pins? How many are they? Somebody to tell me if they can see digital pins.
And I think Wango, if anyone is using Arduino Mega, they might have more pins.
Okay. So for the Arduino Uno, which is one I'll be using, we can see we have digital pins, which have been named from 0 to 13, which means we have 14 digital pins. So this is where we are going to be connecting our inputs, our digital inputs and our digital outputs. So I'll be explaining more on that. So an example of an example of a component you're going to be connecting there is an LED, like you saw in the picture. And also if you have a button or what most of you know as a switch, we are going to be connecting them there. On the other side of the Arduino board, we have the analog input pins. So in this case, if you have a sensor that you are working with, you won't connect them to the digital pins. You're going to be connecting them to the analog pins. The last thing I think which is relevant is the DC power jack. So we agree that the USB can be used to power the microcontroller. But let's say after you have programmed it and it's working well, you've transferred the code, but then you want to use it like far from the laptop, you can't continually power it using your laptop. So if you have like a battery, a 15-volt battery, you would connect it to the DC power jack. So this is the hardware bit of it. Now I'd like us to go through the integrated development environment. In other words, the Arduino software. So let me open it up. Okay. So this is where we're going to be writing our code from. This is something you can just download. You can just Google Arduino software download and it will come. When you open it, it's already set up like this. So I think just one thing I'm going to do is I want to increase the writing to, let's say, 24. Yeah, is it clearer? I think, or I can just add a bit. Okay. So this is where we're going to be writing our code that will ensure our projects work the way we want them to work. I think another important thing to add is, as you can see, I don't have the code lines. The code isn't numbered. I think for it to be easier for you to answer or for me to demonstrate, I'll also just go to preferences and then I'll display line numbers. So in this way, if I tell you to look at line number 4, we are all looking at the same line just to ensure we are on the same page. So this is where we're going to create our code. And just to do a quick run through, this space here, this white big space is our sketch area. This is where we're going to be writing our code from. And then if you can see my cursor as it's moving, if you save your code, this is where the title of your code will be displayed. And then we have 5 icons at the top. 1, 2, 3, 4, 5. So if you place your cursor on it, it will actually read to you what it is. So the first one is to verify. So after you've written your code, there are some rules that need to be followed. So if you break any of the rules, after you're done writing your code, you'll verify it to see if there are any errors in your code. So that's the first thing. So if you do find an error, so let me just verify this code. As much as it doesn't have much, it will tell you it is compiling the sketch, and then to tell you it is done compiling. I hope you can all see done compiling below. So that is the message area. So it means it is fine. But let's say, for example, accidentally, I delete this curly bracket on line number 6. Let's say if I delete it, and then I try and verify. Okay, first let me save it. I'll save it as LED. Let me save my code. So if I verify it, what does it tell you now? Expected initializer before that curly bracket token. It will try and let you know where your error is. So it's good practice after you write your code, you verify it first before attempting to upload it. So I know where the error is. So I'll just add back the curly bracket. So sometimes it may take a while before you realize where the error is. So I think especially for the newbies, it can be a bit frustrating, but just don't give up. Sometimes also you need a second eye. If you can't see where the error is, you may just need to ask somebody, hey, I have an error in this code. come and help me troubleshoot. The next thing is to upload. So once you've verified your code and it works fine, you can now upload it using this second icon. So this one is when you need like a new sketch area. And then if you save your program, the next time you open this software, you can open an already saved project using that icon. And then once you're finished writing your code, the last one is just for saving. Okay. Are there any questions? So that's the Arduino hardware, and we've gone through the Arduino software. So I would like us to now go through the other components that we will require to blink an LED. So when I displayed my project, and I think I can display it again. What apart from the Arduino, which other components do we need for this particular project? Because it's a bit obvious. You can build it on chat.
The whiteboard.
The whiteboard.
That board you've in your hand.
Okay, we need this whiteboard, but it's called a breadboard. So we'll need a breadboard. And I think Brenda mentioned that this was an LED. So we actually need an LED. And if you look closely, we also require a resistor, and we need some jumper wires. So we can just quickly go through what those are. Okay, so okay. So this is the one Brenda has mentioned, a breadboard. So this is where we're going to be building or placing our components. And it's actually one of the reasons also just like the breadboard is that once you make an error, it's very easy to correct it. So most times this is used as the prototyping platform before you build your final product. So the picture, it has been placed like horizontally. So let's all just look at the second diagram below it. This one, it shows us how those dots are connected. So like behind it, there is some conductor. So for these top holes, they are connected horizontally. But then when you come to the middle one, the holes are connected vertically. Please don't wonder what I'm talking about. This will become clearer as we actually build the project. But for now, just remember that the top ones are connected horizontally. The others are vertically. But then also there's like a bridge in the middle. So there is no connection for the vertical lines. There's the vertical line, then there's a break, then we have more vertical lines. So this will be very important when using the breadboard. So this is the LED that you're going to be using. One thing for you to just remember is that it has two terminals or two legs. I don't know which one. I think I gravitate towards calling them legs. So there's a longer leg and the shorter one. So the thing you need to remember is that the long leg is our positive terminal and the cathode is the negative. Yeah, Millicent, I see you holding your LED. That's great, nice.
So I've raised my hand, but it seems you didn't notice me. So okay. I wanted to just, when you're talking about the breadboard, sometimes because of different manufacturers, you might have different appearances. Like for this one of mine, in the middle, there's a disconnect. So if anyone has a similar model, they'll need to know if you're using this side of the breadboard, it's okay. But if you're using the entire board, you have to connect the two sides using the jumper wires. So you just have to put like a link where, like if the red line and the blue line are not continuous, it means your two sides are not connected. So you have to connect them with a jumper wire. one for the blue line and another one for the red line, and that both sides up and down. That's just one thing I wanted to make sure everyone understands, so that in future you don't experience open circuits.
Thank you, Brenda, for that. Actually, when I do like a double, when I look at my breadboard, I think we have the same breadboard. Mine also has the break. It's not like continuous from end to end. So please have that in mind. So I'll continue sharing my screen. So next we have the resistors. I think when I mentioned about resistance, it just limits the amount of current that flows through a circuit. So when you get these components or when you buy them, there's something called a data sheet that you can just Google, like a data sheet for a particular LED, for you to understand the current that component can withstand. So once you understand the maximum current that it can withhold, you'll be able to calculate the resistor that is required. Because if you notice, these resistors all have different colors. I won't go deep into how to calculate to get the colors, but always remember that different resistors have different colors, so they have different values. So for this particular project, if you have your 220 ohm resistor, so it's a blue one. I think I should have put like a picture of it, but it looks something like this. So it's red, and then brown. So if you have this one. So let me just let me get for you the colors. Yeah, but Millicent, it does look like it's the one, and it's the one which usually comes mostly with this kit. So we're gonna be using the 220 ohm resistor. So this is done from calculation to ensure we don't burn our LED. Then the last thing is just the conductors that we'll use to connect from the breadboard to the Arduino. So I really like how they're usually colored. They make the connections look quite interesting. And I think that's what we need. Okay. So it's quite obvious. It will be impossible for me to connect the physical Arduino kit on camera. So I'll just open my whiteboard. Okay, first I need to share. Okay. 1 second, please. I get the right whiteboard. Okay. Okay, so sorry about that. So for the connections, so as I connect it here, just try and translate it on your physical board. So we have our breadboard, and we have our Arduino, and we have our LED, and we have our 220 ohm resistor. So how are we going to connect it? So first, I mentioned we have the digital pins. So the digital pins is where we're going to connect either our inputs or our outputs. So just a second. Okay, so let's decide which digital pin we would like to use. For this example, we can let's use the digital pin number 8. Okay. So wait. So once you have your LED, you can all pick your LED and place it on your breadboard. Place it on your breadboard. This middle, the middle part where the connections are vertical. There are very many different ways you can connect your breadboard, but just for the sake of this first example, maybe we can just try and do something similar. So ensure you dig it, you put the legs, the terminals deeply in, okay? So once you connect that, we need to protect our LED from too much current. So we need to connect our resistor. So I want somebody to tell me, will I connect the resistor to the positive terminal of the LED or the negative terminal?
You connect it on the positive terminal.
Yes, you connect it to the positive terminal because we want, before it reaches the LED, the current has been reduced. So I'll pick my resistor, and then the thing is, let me use my, okay, the whiteboard is clearly not the best to illustrate this, but just try and keep up. Or maybe I should increase the size of the board. Okay. Let me leave this. So you need to ensure the terminal of the resistor, where I have the red dot, and the terminal of the LED are on the same line to ensure they are connected. If I come and connect my resistor on this dot, they won't be connected. So you need to ensure they are on the same vertical line, okay? I hope we are clear up to there. So now we have the other terminal of the resistor, which is hanging. So for that particular terminal, you can just put it anywhere but below the bridge, because remember, there is no connection after that bridge in the middle. So this, so now we have connected our LED, and we've also connected our resistor. So the thing which is going to power our LED, we decided we're going to use the digital pin number 8. So let's take a jumper wire. Take your jumper wire. And for those who don't have, let's just do it together here. So, and ensure you place it in the right hole. At least for pin number 8, it's not usually a difficult one, but sometimes when you're trying to use digital pin 11, when you use your eyes, you may think you've put it in digital pin 11 and maybe it's actually in 10. So sometimes I usually just count from below 0, 1, 2, just to ensure I've used the right one. So let's take a jumper wire from digital pin 8, and now we will connect it to the resistor. So, pardon, I'm sure my line won't be straight. So if you're following, notice that the jumper wire needs to be on the same line with the other terminal of the resistor to ensure they're connected. If you come and place it in these other rows, it won't be connected. And remember, a circuit needs to be a path. And if it's broken, and if that path is broken, you won't have a complete circuit, and hence your circuit, it will not work as it is supposed to work. So do you guys think we are done connecting? Do you think we are done, or is there something missing?
Yeah. We need to connect the ground.
Yes, we need to connect the ground. So at this point, we have the power that's flowing from the Arduino from digital pin 8. it goes through the resistor where the current is kind of reduced to ensure that, our LED is safe. But then if you notice, the negative terminal of the LED is still hanging. So we don't have a complete circuit. So what we're going to do is we're going to take another jumper wire. Maybe this one needs to be longer than the other one. So we will connect it from the terminal of the negative line to ground on the Arduino. Okay, now I have a question. Do we have a complete circuit? Yes or no?
Yes, the circuit is complete now.
Okay,
No,
Emmanuel says it is complete.
no, it's not yet complete because the negative leg is not in the right hole.
Exactly. I'm snapping for Emmanuel. I think he's really understanding how to connect this. So this will not work because this second wire that I placed, it's not connected to the negative terminal. So this actually needs to be here. Because now, okay, let me change the color because it needs to be on this same line. It needs to be on that same line for it to be connected. Then the last thing would be for us now to connect our USB to the laptop. So I hope we're on the same page. I think I'll stop sharing my screen so that now we can go to the software bit. Okay, so with this particular platform, there are already examples which have been done for us. So in your free time, you can just go. You can just go through them. But since this one is a very short code, we can just all write it we can all write it together. So first thing you'll notice is that this code, it has two main functions. We have the void setup and the void loop. And just like a normal language, which has its own rules and syntax, the same applies for Arduino. So you'll notice there are curly brackets. Sometimes after you write a statement of code, just like in English, usually end a sentence with a full stop. This one you'll need to end it with a semicolon. So we have the void setup. This will just be read once. So it's you just letting the Arduino know how you have connected it. So in this case, which pin did we use to connect from the diagram that we did? Which pin did we connect our LED? Who remembers?
Pin 8.
Number 8.
Pin number 8. So we have the pin, and then we have the pin mode. So for the pin, for the first part, the pin we have all agreed is pin number 8, and our LED is an output. So it's outputting. We are telling the Arduino to switch on the LED. So it's an output. Because realize when you use things like buttons or switches, they are inputs. Because the Arduino will have to read if a button has been pressed or not. So this is why we have to come and let the Arduino know that the thing we have connected there is an output and not an input. Because it's the Arduino which is going to tell the LED to come on or to come off. So we are done with the first function, which is the void setup. Very short. We're just letting it know that we have connected it to pin number 8 and that it's an output. The next one now would be the void loop. So this will just run continuously. Whereas the void setup is read only once, the void loop will, as long as you've connected your Arduino to the laptop or you've powered it, it will continually be reading it. So we want to have our Arduino, our LED come on. So we're going to write digital write. And the digital pin that we used is 8. And this time, because we wanted to come, the LED to come on, we're going to have here as high. And remember, we finish a sentence or a statement with a semicolon. So this particular code now will just bring our LED on, but we need to switch it off. So I'll just copy paste this. So instead of high, what will we have?
Low.
Low. But then how the program works, it usually runs line by line. So it will read line 1, line 2, line 3. Then when it reaches line 8, it will find a command to switch it on. And then line 9 is telling it to go off. So these two are too close to each other. So we need to add a delay in between here so that we can actually have time to see that the LED is actually on. So we're going to add a delay statement, and the Arduino understands it in milliseconds. So if we want it to be on for 1 second, what will I write here?
1,000.
1,000. And then I would like it to go off before, to be off for also another second. Okay. So once you think you're done writing your code, what are we supposed to do?
To verify
Verify
your code.
Yay, yes, we verify it first to see if there are any errors. And good for us, there are no errors. So some of the errors you may expect are, some of you may forget to add the semicolons at the end of statements. So remember to add these semicolons. Also, when it comes to pin mode, if you have a small m, let's try and verify. Let's see if it will work. It won't. So sometimes I'm telling you, it can be so frustrating because the error may be so small, you may not be able to see it. So you may actually need to take a break before you, especially if your code is very, very long. So once you've verified it and it's okay, and you have connected your hardware, it's good practice to come to tools. You can see here we have the file, we have the edit. So we have our tools here. It's good practice to just come and ensure that you have connected the correct Arduino. So in this case, we are using the Arduino Uno. I know Brenda's Arduino is the Arduino Mega, so she will actually go to the Arduino Mega. So just ensure that is connected. And then you'll also need to ensure the ports you're using. So in this case, mine is using the COM4. And I know sometimes you can be able to, Kelly, I see you have a question.
Excuse me? Yes, I do.
Yeah.
You are talking about Arduino Uno and Arduino Mega, right?
Yeah.
What's the difference?
So Arduino has different boards. And sometimes, depending on the complexity of the project you're building, you may choose a different board. So Arduino Uno, you can just think of it as the entry-level board for you to learn.
So it's basic and elementary. Arduino Uno is basic.
So, like, can I assist Wango? So even in the names themselves, it's even like different sizes. So there's Uno, it's a standard size, which Wango is currently using. Mega, it's slightly bigger than Uno. That means you get more pins, like analog inputs and digital outputs. The the current and the voltage is the same. And then we also have Arduino Nano, which is even smaller than the Uno. So if you're building a project that is very limiting in terms of space, a Nano. So you could choose, like Wango has said, depending on the size of the inputs that you have, how many outputs you want, you could choose a different board. And the only thing you will need to do is, under tools, specify which board you're using. So the moment you connect USB to your board, your IDE, the Arduino IDE will detect which boards are available to choose from.
Okay,
I hope that's
thank
helpful.
you. Thank you, thank you.
Okay, so once we have ensured that, then the next thing would be for us to just to upload our code, and it will in the message area below, it will show you uploading. Just be patient. Uploading. Okay, it's taking long. Maybe I should take my advice to be patient.
It's loading.
Well, this is taking long. Since it's a very short program, then I should have. Okay, so for those who are building their own projects, are you done writing the code? Has it uploaded? Okay, because of time, I say I have like 5 more minutes remaining. Once it has uploaded well, on the message area where at the moment it's written uploading, it's going to change and become done uploading. So then that happens. You'll find your LED blinking every second. Please, your code may be fine, and once you upload, your LED is not lighting. What are some of the things you would do to troubleshoot? So you've written your code, it's fine. You've verified it, it has no error. You have uploaded, it is done uploading. But then when you look at your circuit, it's not working. So maybe people can share what they think would have gone wrong.
Probably you fix the cable in the wrong pin. Digital pin might be wrong, and then probably the negative wire is not in the same hole as the LED.
Yeah. So yeah, so he has mentioned in the program we have that we've connected to digital pin 8. You may have accidentally on the Arduino, you may have accidentally put digital pin 9. So you need to check that. Another thing that usually confuses people is the breadboard. So sometimes you may find you haven't connected them maybe on the same vertical line if the connections are here. So just take your time to go through your circuitry step by step to ensure that you've connected it well. And then for that exercise, we have done blinking an LED, and this is just like a first step. So because now from this, you can add more LEDs. So for example, if you want to build traffic lights, we already have a green LED, so you just add a red and an orange one. But remember, once you add the LEDs, each LED will need to have their own resistors, and also the program. The program we have written right now only recognizes that one LED is connected. So you need to tell your program that you have added more LEDs to the digital pins. So you expect your program to become longer. In the case I was given an example of using a button or using a switch. So you can actually even build this, expand this project by adding a button where you're able to program your Arduino in that if I press the button, the LED comes on. If I stop pressing, the LED goes off. But if you notice, that one requires like human input. But somebody has to come and press it. So what about if you want it to press itself automatically? This is where we now introduce sensors. The sensors which I mentioned, which are connected in the analog pins. So it could be that you want to create a system that switches off your lighting system automatically. So you have a sensor that's able to measure the light in the environment. So when it becomes dark, then your LED should come on. I'm just trying to show you that the possibilities are endless. And one thing I got from Felicity, just have an end goal of what you want to learn. All this material is available online. As a beginner, you'll find yourself learning a lot from people's code, you changing it up to suit what you want. But eventually, the hope is that now you're able to just do your project from scratch. For those who have the kits, I think after the session is over and we have stopped live streaming it, we can just stay behind and then we can build up on this circuit to build the traffic lights, at least just for practice sake. Even if you don't have the circuit, you can just stay behind for us to build up on it.
But there's a question you asked on what could be the problem. I think Dan gave some good responses there. Trying a different LED, because sometimes you are using an LED that is burnt out. The same way in your house, if you switch on your light and it's not coming on, it could be the bulb is burnt. So testing your LEDs to make sure they're working, then checking also the resistor value. So sometimes you use such a huge value like kilo ohms and it resists so much current that not enough current is reaching your LED. So I think those are really, really nice inputs to mention.
Okay, I'm just curious, anybody who has built their circuit and it's working or not working?
Mango.
Yeah.
Mine is saying, after trying to upload, it's saying couldn't find a board on the selected port.
Okay, go to tools.
Tools,
yes.
Okay,
Check first the board. Which board is connected?
Which what?
Board. When you go to tools,
if you select the board, you should be able to see a list, and Arduino Uno should be one of them.
Yes, mine is at Uno.
Then there's just below the board, there is port. You see port?
Yes.
What's written there?
Serial ports and COM5.
Is there one with brackets that says Arduino Uno?
No.
Maybe just select COM5. Could be that's the USB for that.
Okay, so select it and then try and upload.
Okay, it's uploading.
Okay, you'll let us know.
Let you know, yes.
And we can continue that troubleshooting, like Wango said, in the offline session once we're done with the session.
Yeah. Unless there's any question, I think we can go to our final demonstrations, and then we can call it a day. So Brenda, please take us through the remaining demonstrations.
So I have with me 2 more videos. One is very brief, less than a minute, and another one is around 4 minutes long. So, and then I had prepared a small demo myself, but technical challenges. So first of all, the laptop I'm using doesn't have a USB port. So I connected it to a different laptop, which again, I'm finding challenges to share. Like the code is not really visible, but I can share the code on my screen. But what I wanted to show is it's a digital thermometer, and this is a common project. And I think I just wanted to show this project because of the current situation we have with COVID, and people, whenever you go to a supermarket, an institution, they want to take your temperature. So that's a simple project you can tinker with. And it's a very simple connection of this. It's called the LM35 temperature sensor. So if you just Google LM35, it will give you like an image and how you can configure it and connect it to your Arduino. So it only has 3 pins. One is connected to the 5 volts input, another one is connected to the ground, and another one is connected now to the analog input on the Arduino board. And then like the code is available on you can like get example projects on the LM35 specifically. It's free online, so you can do that. And once you upload, I was able to display like the temperature. It displays the current temperature in my room. So at the background over there, I think you can see like different values coming up. So I've set them to show up at intervals of 2 seconds. So every 2 seconds, every 1 second, I get a reading. So right now I'm seeing 24 degrees Celsius, I'm seeing 25. So the current temperature in my room, in my sitting room, is ranging between 24 and 25 degrees. In the morning, it was a bit cold, it was 22. So right now, because it's a bit warmer and the sun is shining, I am getting like a higher temperature. So this is just an example of how you can use Arduino to implement simple things that are ongoing. And then another thing I wanted to share, back to my camera, I wanted to share this video again. This was sent in by Keith Bryan, who is obviously very loves tinkering with Arduino, and they created an automatic dustbin that you can use. If you don't want to touch the bin to open it, you can use an automated dustbin, and I'll just go ahead and play it. Yeah, I know some of you might have seen applications of similar, especially like for the ladies, the washrooms, when you're disposing, your toiletries and things like that. You've seen similar applications, because then you don't want to touch a dirty surface, because it's a dustbin. And the next video, and I hope, Keith, you can upload this on the Arduino project hub and share a link with the code, so that people who want to modify it or create it, and I've seen similar projects, students trying to build automatic dustbins in their school. So if you could go ahead and share it in the projects hub, and then we can help them learn more from the code that you used. Did someone say something? Wango, is that you? The final video I want us to watch is a student called Rebecca, and I know Richie mentioned her in the introduction. She's been a student at InLab, went to InChallenge, and now is working as a backend developer. And recently we had a sit down with her, and this is what she had to say about her experience in Gmail.
Rebecca Omboy. I'm a backend developer at Trigger Foods, and as a backend developer, I take part in the development lifecycle to make sure that I write clean code for web development. I'm also a Global Minimum 2018 alumni. I joined Global Minimum in 2017 as an in-lab participant, and during the in-lab period, we were taught basic circuitry and programming using C++, and I really liked the mentorship and also the coding programs which we were taking. They really inspired me, and through that knowledge that I gained from in-lab, I applied for In Challenge with a team of 3 and came up with a project called the Speed Bump Detector. So basically, a speed bump detector is a gadget that is installed at the bumper of the car, and whenever a car approaches the bump, it gives some signals to the driver so that the driver can slow down or stop so it cannot hit the bump. So that was to help reduce road accidents caused by unmarked speed bumps and overspeeding. So when I was still at Global Minimum, I attended various events, one of them being African Women in Technology, hosted by Akira Chicks. And from there, I was so inspired by various young women who are part of technology in tech, who are part of tech, and some of them had very awesome projects and very good ideas in the technological field. And so I didn't know that few years from then I would join Akira Chicks. So Akira Chicks is just a platform that inspires young women to be in the tech field, and inspires basically young women to be in the tech fields. And then also attended London International Youth Science Forum in the UK, and I participated in that program as the only Kenyan for a period of 2 weeks. Yeah. So 1 week before I started my KCSE, Wango came to our school at the People Children's Center and told me about Akira Chicks, more about Akira Chicks and how they offer the Good Health program, especially for ladies. And I got so interested in that program. So after I finished my KCSE in 2019, I got a phone and installed a certain app called Sululan, where I started self-teaching myself HTML and CSS, the basic programming languages. And I didn't know at that time that the Akira Chicks opportunity is going to come my way. So after some few weeks, Brenda called me and she told me that the applications are now open. So she helped me out in applying for Akira Chicks as my mentor. And after I applied, I went for an interview and then passed the interview. And now I was now enrolled into the Code Hive program in now 2020. So in 2020, we had a program for 2 months. And then when Corona hit our country, we had to go home and learn via WhatsApp for 3 months. And after that, we now came back to school in July and started using Zoom as a way of learning. And then now from there, we were still applying for internships because at the program, you must have an internship before you graduate. So we applied for an internship and I applied at Trigger Foods where now I'm currently working as an apprentice. Yeah, so I think one thing that I'd like to tell young people is always being open-minded, always be ready to learn. Whichever opportunity comes your way, be ready to learn it and grab it with all your heart because you don't know the impact that it's going to impact on your life. Don't have a fixed mindset where you only want to do a certain thing and that's what you really want to be like for the rest of your life. Be open-minded and then be eager to learn whatever that comes your way. Be curious, be eager to learn, and then be open-minded and always think out of the box. And also another thing, always be persistent in terms of when you find something and maybe you're not very familiar with it or maybe you don't know how to do it, follow up and know how it's being done. Follow up and know how you can be able to tackle a certain thing that's maybe you don't know how to tackle it. Be persistent, be curious, and also be flexible. Maybe, for example, you wanted to do something and maybe it doesn't work out for you. Always be flexible such that when another thing or another opportunity rather comes your way, you're able to adapt into that line and you're able to follow up with that so that you can make your life better. You just make your life better. I think that's it for me.
Okay, that's it. So that is just a story from one of our students, and just from one experience with Arduino. That's how her interest in coding was sparked, and now she's living the dream. She's working as a backend developer. That's really inspiring for us, and that's what we try to do at Jimin: inspire more, women, young girls, youth to join STEM careers and pursue what they really enjoy doing. So yeah, I'll hand it over to Wango. I think I've talked so much in the past few minutes. Yeah.
Oh, it's good to see that we are actually going to close on time. We have like just 3 minutes left. And I'm glad we didn't keep you longer than our schedule had indicated. So I'd really like first to appreciate all of you for joining our online event. I hope you have learned something, and we have also learned from you as our community. So yeah, we really appreciate that, and I just encourage, especially the students who are on the call, to continue learning and exploring this particular tool. But also just feel free. There are even other tools, programming languages that you can start working on. It doesn't matter the career you have decided to pursue. I feel like it really helps with, even as Mr. Kelly had said, it just helps you with your thinking capacity. You're able to reason quickly, logically, be able to analyze data, and maybe before coming up with a conclusion. So don't think, oh, I want to become a XYZ and I don't think it needs programming, I don't think it needs this. If you have an opportunity to do it, just do it. Students from our in-lab partner schools, you all have these kits in your offices. Yes, at the moment, in-lab is on hold. We haven't been having the sessions, but take that opportunity to meet up with your teachers. You have the workbooks. Just sit down with your peers and test out different projects. Lastly, we have shared our social media pages. So feel free when this is over. If you tweet something, if you do decide to tweet or to post something, tag us so that we are able to reshare. So yeah, thank you so much. And I promised you that after this is up, we can stay behind to build, for those who are interested, for us to just quickly expand our project from just one blinking LED, and maybe we can create some traffic lights. So I think I'll stop live streaming it.